Welcome to the 8th week. So up to now, we learned all the fundamental object-oriented programming concepts and many other related concepts as well. So in this lecture, let's use two case studies and learn how to implement an object-oriented program as a solution to a simple problem. So pause here for a minute and read this given description of case study 1. You have to identify the objects, their attributes, and the methods as mentioned in the given description. So here I have marked what I have found. As you can see, we have identified some objects and some attributes, but we don't see any methods here. So we see a bicycle shop object, motor bicycle, foot bicycle, which in turn can be adult foot bicycle or kids foot bicycle. And each bicycle has a color attribute. Motor bicycle has an engine number as the attribute. Foot bicycle has a bell. Adult foot bicycle has a lamp. And kids foot bicycle has a pair of stabilizers. Now let's see how we can get this information into a piece of Java code. So to begin with, we group all these classes into the bicycle shop package, which is a nice logical grouping. So let's start with the bicycle object. So as you just read, we have different types of bicycles, which indicates that our bicycle has to be a superclass for all these bicycle types. And it was mentioned that all the bicycles have a color attribute. So this common attribute can easily be put inside the superclass bicycle. And as you can see, we are setting the value of this color inside the constructor. And to support or to make sure we have the encapsulation used, our color is a private attribute and it is exposed through the public getColor method. And in this bicycle shop, what it creates is either a kid's bicycle or a adult foot bicycle or a motorbike. So we will not be creating bicycle objects. So because of that, to make sure no one goes and creates objects from this bicycle class, we declare this class as abstract. So you won't see any abstract methods here, but we learned that a class can be made abstract even when there are no abstract methods in that class. Here's the logic for the motor bicycle. It extends a bicycle class. That means the color attribute is inherited by the motor bicycle now. In addition, it has the engine number. So this color attribute has to be set based on the value we get from outside. So motor bicycle constructor has a color string parameter coming in. However, inside the motor bicycle class, we don't have any color attribute to set this value. So what we do is we use the super keyword and pass the value we have to the superclass constructor where the color attribute will be set. Now we have to set the value for the engine number. This engine number has to be unique for each bike. So what I have done here is to demonstrate the use of static variables, I'm using the bicycle count as the engine number. So what have I done here? So I have declared a static variable to record the number of motor bicycles. So this variable is incremented inside the motor bicycle constructor. That means every time when a motor bicycle is created, this number is incremented. So always the engine number will have a unique new value. Now here's the foot bicycle class, which extends the bicycle just like the motor bicycle. So on top of the color attribute it inherits from the superclass, it has its own bell attribute. And foot bicycle can be of two types, the kids bicycle and the adult foot bicycle. So because of that, we will not be actually creating foot bicycle objects. So in order to impose that restriction, we are making our foot bicycle class an abstract class. Finally, here's the kids bicycle. So similar to the other class, it inherits the color property, and the value is set through the super keyword, and it has its own property, the array for the stabilizers. And then the adult bicycle, just like the kids bicycle, it has to extend the foot bicycle. It has a lamp as its specific property. So now pause here again and read the second part of this case study. So here I have identified division object, which is said to have two subtypes, the assemble division and the quality check division. And all the divisions have a unique name, which is the attribute. And we can identify some verbs here which may become the method. So the request, create, check, and pass. Some of these, as you will see, be implemented as methods. So first, we will define the needed classes. We have a division superclass because it contains the common properties for the assemble division and the quality check division. And since we are not going to create division objects itself, this class is abstract. And here's the assemble division, which extends the division, which means the assemble division is a subclass of the division superclass. So because of that, the name is set through the super keyword where the value is set by the division superclass constructor. So what the user specify is the name of the byte type as a string. So we have to take it, and then depending on the type value, we have to create the appropriate bicycle. For example, if it is a motor bicycle, then we have to create a motor bicycle. And likewise, we have to create different types of bicycles based on the string type value. And if the user type is not any of these, it will be returning the null value for the B. And see the use of polymorphism here. There are two use cases here. First, the return type of this assemble method is a bicycle superclass. But when executed, what does it actually return? To return an object of either motorbike, adult bike, or kids bike. So, and again, in the second instance, so we have a bicycle B variable. So this B variable is of type bicycle. But what is it assigned to? In some cases, it will be assigned to a bicycle object. In certain cases, it will be an adult bicycle object or a kid's bicycle object. So we define a superclass variable, but later we assign it to a subclass object. So here, a nice use of polymorphism in two cases. So here is the quality check division. Now it has a requirement that it should check quality only of the kid's bike and the motorbike. So in order to satisfy that, what can we do? So one not so good option is to have two methods. One check quality method will take kid's bicycle as the parameter. The other check quality method will take the motorbike as the parameter. So the same function to implement, we are implementing two methods, which is not a good design. The other option is for the check quality method to take a bicycle object as the parameter. What is the problem there? So it will of course support kids bicycles and motor bicycles, but it will also support the adult foot bicycle, which should not come here because we are not going to check the quality of the foot bicycles. So what is the solution? So here we are going to use the concept of interfaces to solve this problem. Specifically, what I have done here, I have created an interface named checkable, and it has the method getQuality. So which classes do you think should be implemented in the checkable interface? It will be the kids bike and the motorbike. So here again, I'm showing the checkable interface, which has one abstract method, getQuality. Now we have to go and modify our motorbike class and the kids foot bike class to get them to implement the checkable interface. So this is what we have done. So now kids bicycle, in addition to extending the foot bicycle, now implements a checkable interface as well. So if it implements a checkable interface, it must have the implementation for the get quality method. So this get quality method implementation is specific to the kids bicycle because it has to carry out certain checks specific for the kids bicycle. So here the return type is Boolean, that means it will be either true or false. So here, based on your quality check, you have to return either a true or false. But here, for simplicity, I have simply mentioned that it is returning a default value false. Similarly, our motor bicycle is now implementing the checkable interface and has its own implementation for the get quality method. Now pause here again for a minute and read the last part of this case study. As you can see, the main requirement here is that our bicycle should be able to keep track of the bicycle object that underwent the quality check. What does that mean? That means our bicycle shop should have a hash map that stores only the kids bicycle and the motorbike, not the adult foot bicycle. So how can we achieve that? So the simplest solution is to use the checkable interface that we have recently introduced. So this is what I mean. So now in the bicycle shop class, we have a hash map that takes a key value pair where the key is a checkable object, which is a unique value, and the Boolean value. This Boolean value is the actual quality of the bike as returned by the quality check division. In other words, what this method has returned. So see what happens in this code. So again, this is a fine example of polymorphism. Now we have a hash map that takes a superclass type, but actually when we put object, we can put different related object types. That means the kids objects and kids bike objects and the motorbike objects. So now look at what happens in the accept order process. So accept order means the bicycle shop takes an order from a user. So for simplicity, we just specify the type of the bicycle as a string variable. So what does it do? It will take this string bicycle type variable and pass it to the assemble method of the assemble division class as a parameter. So that means if we go back, so this assemble division assemble method will create a bicycle and return. And again, it's the use of polymorphism because our bicycle object is of type bicycle. But what the assemble class, this assemble method returns is either a kids bicycle, adult bicycle, or a motor bicycle. Now, the quality is checked only if it is a kids bicycle or a motor bicycle. So, in order to guarantee that, we have this if condition. So, what does it do? It checks whether a bicycle is type of checkable. So, that means if it is either a kids bicycle or a motor bicycle, this if condition will be satisfied. So, now this object that we created, the bicycle object, now we pass to the check quality method of the quality check division. Now here what we get is a object of type bicycle. The bicycle is defined as a bicycle object, although the what it reference can be a kids bicycle or a motorbike. So since the bicycle is of type superclass bicycle, it cannot be put as a parameter to the check quality method. Why? Because if we go back again, in this check quality method, what it needs is a checkable object. So in order to convert our superclass bicycle object into a checkable object, we use this downcast. So And then now we can pass that the casted object as a parameter to the check quality method. And what it returns is the Boolean value. Now this Boolean value along with this bicycle object, we put into the QC info hash map. So here's the rest of the implementation of this use case according to the given description. So you should try out this code. First try it on your own, and if you have any issues, try to correct them by referring to the code given in this lecture. Let's move into the second case study. So pause here for a minute and read this given description. So basically we have two main object types here. One is the beverage machine, other is the beverage type. So beverage type can be either tea, coffee or water. And we can easily identify an interaction between these objects. That means the beverage machine produces the beverage. So let's have a look at the implementation. First of all, just like in the previous case, we are packing all our code into the beverage machine package. So first we'll implement the beverage cup class. So all the beverage cups has an unique integer value. So that can be put into the beverage cup abstract class. And we also record the total number of cups created. And since the beverage cup is a superclass, when we have this static variable in the superclass beverage cup, whenever a subclass object is created, this will be incremented. Why? Because every time a subclass constructor is called, by default, the superclass constructor will also be called. And just like in the previous use case, what we are creating is either teacup, coffee cup or a water cup. We will never be creating objects from the beverage cup. So because of that, we can make this class abstract. And there's another reason to make this beverage cup class abstract. As you can see, the get type method. It is mentioned that it is specific to the actual cup type. So there's no way that the beverage cup class knows how to implement this get cup type method. So because of that, inside the beverage cup class, this get cup type method is an abstract method. So if, as I mentioned earlier also, if a method is an abstract, that class must be an abstract class. So it is also mentioned that we have to check the calories only for tea and coffee. So similar to our previous case study, we should make sure we omit the water cups from this check calorie method. So because of that, in order to group the cups that contain calories, we introduce the interface checkable. So here's the implementation of the three classes. As you can see, all three classes have to extend the beverage cup class because that is a superclass that contains the common attribute and methods. And as you can see here, the beverage cup class has the get cup type abstract method. So since any of these method classes are not abstract class, they must implement the get cup type method in their implementation. In addition, the coffee cup and the tea cup must implement the checkable interface, which guarantees the calorie count can be calculated only for these coffee and tea cups. So the check calorie method has to be implemented. That implementation is specific to the corresponding class. Now, with this checkable interface, we can easily satisfy our requirement that the beverage machine must record the cups that contain the calories. So rather than having multiple array lists where one corresponds to the teacups and the other correspond to the coffee cup, and rather than having cup array list which can beverage cup array list which can also include water that does not have any calorie, what we can do is we can have an array list of type checkable. Again, this is polymorphism, because although the type of the array list is checkable, when we actually put objects to this array list, what we put is either a coffee cup or a tea cup. For example, see here. So we create a beverage cup, and if the user wants a coffee, our what we create is a coffee. And see here, and again polymorphism here. So we have a beverage cup, which is first null, and then depending on what the user wants, we either create a coffee cup, tea cup, or a water cup. So this beverage cup is assigned to objects of the subclass within this different if and else if condition. So we define the variable belonging to a superclass, but it is assigned objects that belong to the subclasses. So, and again, what we return is a superclass. What we say we return the superclass object, but during the execution, what we actually return is an object of the subclass. So polymorphism is all over this. So in this specific example, you can see 3 places where polymorphism helps us. That means having a checkable array list and the produced beverage return in the beverage cup superclass object, and this beverage cup attribute being assigned to the corresponding subclass objects based on our logic. So here, as per our requirement, only if it is a coffee cup or a tea cup, we are adding the created object to the calorie drinks checkable array list. So here's the rest of the code where we implement the whole given scenario. So you can read the scenario again and try to implement it. And if you have any issues, you can refer to the given code and try to resolve those problems. So with these 2 case studies, we learned the application of many of the object-oriented programming principles and related concepts that we learned throughout the previous lectures. So now in the next, so now what we have actually learned up to now is how to, just go ahead and implement an object-oriented program. However, when we develop a large-scale complex system, we can't just go ahead and read the description and implement the program. So before implementing, we have to design our system, object-oriented system. So in the next week, we will learn how we can consider the designing phase of object-oriented programs. Thank you.